Welcome back everyone to Master Game Design, Unreal Engine 5 Stylized Environment and Third-Person Blueprint course. In the last lesson we left ourselves off with a blueprint buoyancy example, which we're going to be changing into for our ship. So if we go on to the viewport tab over here and zoom out a little bit, we can see that this is the box, and we can see that it has a static mesh as well as the buoyancy. So this is what we're going to be keeping. The static mesh itself is not going to be needed for us, but we're going to be changing this to a ship directly. So we're going to just make this window a bit smaller. We're going to find one of the ships. So I think we can start with just this ship over here, the medium in size. I think that's going to be quite all right. Let's go ahead and make use out of that. So we're gonna go ahead and select this. We're going to click on this button over here after the selection, which will drop us into the content browser. And we're going to just have it dragged and dropped into the static mesh itself. So yeah, let's go ahead and do that. We're just going to drag and drop it just like that, which will give us a nice type of a setup. I will actually make use out of the back functionality within a content browser, which will allow us to just go back to the ships folder. And as you can see over here, we have a buoyancy example set with a ship. However, at this point, it's still not quite there with the overall setup. If we play, we can see that it's, for starters, a bit underwater, and it's even drowning and whatnot, and it's quite a mess when we jump on top of it. So there's a lot of work left to be done with that. First things first, we're going to go ahead and fix ourselves up with the points of buoyancy. So if we go on to buoyancy itself, we can go on to buoyancy data. Yeah, there you go. And there's going to be something called pontoons. It has 4 array elements. As you can see, that means it has 4 different points of buoyancy. Each one was attached to the cube. Right now it's not going to be visible, so what I recommend you doing is to actually see how those buoyancy points affect your ship. Is going to be, if we were to load this, actually I'll keep this a little bit above to the side, we can basically go on to a command, and there is a very nice functionality for the command. So at the bottom of the screen where there is enter console command, we can just type in r.water. Oh, sorry about that. I'll just retype it again. r.water.debug buoyancy. There you go. So once you type it in, you should find yourself this command. Just go ahead and click on it. And if you just have a value of 1, you'll turn it on. If you have a value of 0, you will turn it off. So you can make use out of that. So by just typing that in, you basically enable a command. Now when we hit play within our environment, we should see, or actually we're not going to see, the reason it's going downwards because it's directly colliding with the water itself. So what we need to do in order to make sure it doesn't just drop into the water just like that, we need to make sure we select the boat and actually drag it above the water itself. So the entire collision is going to look like that. And as you can see now, we see like some dots. I will actually go ahead and eject the camera a little bit so we can see it a little bit clearly. We can see the dots over on the sea, which act as collision for the water, and we can see these spheres where the cube was. It's acting as buoyancy pivot points, the ones I talked about, arrays over here, array elements. We're going to need to basically adjust them to the ship to make it a little bit larger, so the ship wouldn't tip for starters when we jump over on top of it and whatnot. So let's go ahead and fix that first. I'm going to just stop playing, which we can do either here or here. Either way is fine. And yeah, we're going to first of all start fixing that up. So we're going to open up all of these index points like so. We're going to start by, actually I'd like to increase the radius a little bit. So the radius will affect the sphere size of those collision boxes. I usually keep it to 150, to be honest. I find it to work a little bit better and more visible when it comes to collisions. Then afterwards we can go ahead and work on the location. So by default it's set as -50, but we're going to be setting it up to a bit of a higher value. I will go to the static mesh real quick just to check that the scale of the boat was set to default 111, which it is. Then afterwards We're going to go ahead and change this to minus 200 by minus 200 just to see how the first one would behave. I'm going to go ahead and hit compile, and then we can see how it basically gets affected. So you can see that this one is going to be way at the back now over here, which is going to be quite all right. And it's looking much nicer. The boat itself is not sinking quite enough. So we might need to fix that in regards to the overall setup. And I think in this particular case for this boat, we might even just keep the radius smaller. I'm going to see it in a bit though. The next one is going to be also the one over here. So that's going to be, I didn't talk about the relative location itself much into it. So these three values is basically, if you hover over, it's X, Y, and Z. And the easiest way for us to see it is going to be on the bottom left of the viewport. We can see there is a small gizmo over here which will tell which is X, Y, and Z. By default, when it's facing in front, this is going to be the plus and this is going to be the negative value. So because we set it up to minus 200, it basically goes from the center, which should be at the very center area. A bit hard to see in this section, so I'm just trying to find a better way of showing it, but I can't really do that here. Anyways, I will just show you with these. So we got ourselves a minus 50 in X, which is going to be going in this direction, minus 50. And then we got a 50 in Y, which is going to be going in front. So this is going to be the front right of the boat basically. And I'm just going to go ahead and set this up to minus 200 and 200 like so. Then I'm going to go ahead and hit compile. Now we can see that the boat, oh sorry, let me just go ahead and go onto the top of the harbor. You can see that the front of the boat is like that. So again, it still needs to be had work in progress, but we're getting there in that end. We might need to even increase the Y axis a little bit further. So we're going to set it up to 300 instead. Then relative location for the other one. So this one is going to be, we can just set it up to 200 and minus 200. I think that's going to be all right. So that's the other side. And then it's going to be 200 and 300 for this one. Think that's going to be quite okay. Let's go ahead and see how this looks like. And again, I need to make sure that I go on to the front, and there you go. We got some parts in the front and these looking quite nice. Although, as you can see, the boat itself is not dipping quite into the water. The first thing that we need to do is probably fix up the way it goes into the water itself. So for that, we could either bring these upwards, but I'll just make it easier for this. I'll just go ahead and actually change this radius to 50. So although it's going to be a bit harder to see the points, but they're going to be way higher up, and the radius is going to make this entire boat, causing it to go outwards like so. As you can see now, it's nicely been placed on the water itself, and it's a bit hard to see. Maybe if we can push it off to a bit more damp, bit more nicer waters. There you go. So it's getting there, but it's not quite there itself. We're going to go ahead and fix that. And first things first, what we need to do is just we need to make sure that it kind of floats a bit higher up. And the way we can do that is if we just fix up the buoyancy coefficient. So that's increasing buoyancy force applied on each pontoon. And we're just going to fix that up by adding, by changing it to this to 30. We're going to compile it. Then we're going to see how this would look like. And there you go. Nice bouncing. Keeps it nice on the water itself. It's going to just forcefully basically keep it on top of the water, which is exactly what we want. The other things is that right now, because of the physics and everything, is just going to be quite messy with the boat itself, within regards to how it behaves to the ship and whatnot. So we also need to consider how we fix that. The thing that we need to do first is going to be increasing the weight of the ship. We're going to go on to the static mesh. We're going to make sure that the physics is enabled for it, which is going to be, if we go to details, we're going to search for physics over here, and there you go, simulate physics. We need to make sure that we increase this. So from 50 kilograms, we're going to increase it to 3,000. and that's going to give us a nice base formation, base work. There you go. It's going to look like it has way more mass, and it's going to behave a little better. It still looks like a bit of a toy type of a physics for this boat. The reason being is that it just bounces. There's too many there's not enough momentum carrying with this. It just, you can see, going up and down and whatnot. So we got to fix that as well. The way we fix it is going to be by going and making use out of something called damping. So within the static mesh itself, we're going to search for damping. There you go, and we're going to get within the physics tab, linear damping and angular damping. Linear damping is going to be something like for the motion itself, so it's when it's going to be like basically how well it's going to be pushed around and whatnot. Right now you can see it's just being pushed around like it's nothing, and this is going to be basically just kind of forcing it to more or less stay in its place. If we change this up to a better value, it's going to give us a much better result. I'm going to change it right now to a value of 1, hit compile, and show you what I mean by that. So now once we change it, we can try pushing it, and you can see it's way harder to push and whatnot. This boat has a way more type of mass to it by the looks of it. We can also jump on it, and we can try like pushing it a little bit. So if you want to increase it a little bit more, there is an issue right now where a collider with the third person is able to just push the boat around if it's just walking into it, which can be fixed, for example, with increasing this, but honestly, I'll just leave it as is. They're not meant to be used or anything of the sort, so that's totally okay. The other thing that we are going to be looking at is going to be angular damping. This is going to allow basically to not switch angles, to not rotate it as much when we click play. We can see that it just wobbles back and forth because when it drops down, this is how it looks like. By simply changing this to a value of 1 as well, we can get ourselves a much nicer type of momentum looking when we drop the boat. So we can just see like this doesn't rotate as much anymore. We can jump on it and stuff, and it's not going to just behave like a toy boat or anything of the sort. I would recommend you increasing the damping to larger boats and whatnot. Maybe this one is going to be more better for a smaller boat, and we can even increase linear damping to 0.5 on the larger one. For now though, I'm going to go ahead and keep it as is, as I quite like the results. And yeah, that's pretty much it in regards to the setup of physics collision. We're going to be turning off afterwards the debugging that we used this lesson, but we still need to set up a couple of other boats, which we're going to do in the next lesson. So yeah, thank you so much for watching, and I'll be seeing